Okay, we're now going to have a look at question E, which is another modulus and inequality question. What makes this one different from D is that we've got a modulus, or an absolute value if you want, on the left and an absolute value on the right. So we're going to have to deal with this a bit carefully. I'm going to do it first algebraically, which is a bit complicated and a bit tricky, and it's going to involve us looking at 4 different possible cases. But after I've done that, we'll have a look at the Cartesian graph version, which is, I believe, a lot simpler, and I think you'll see the advantage. But let's at least start off with the algebraic version. So I'll just zoom in on the question. Okay, so here we go. Algebraically, we're going to need to look at 4 possibilities. The first possibility is that the thing on the left inside the modulus and the thing on the right inside the modulus, that they're both positive. And if that's the case, we don't even need the modulus signs because we're just dealing with positives. So let's write that down. So we've got x plus 1 has to be greater than 0, in fact greater than or equal to 0. And x minus 2 is greater than 0, or indeed greater than or equal to 0. If it's greater than or equal to 0, the modulus is not necessary. So let's write it without the modulus, like so. Now let's solve that. Well, what we interestingly notice is that we've got x on both sides, so let's subtract x, and what we get is 1 is less than negative 2. Which of course is nonsense. 1 is never less than negative 2. So this should get our attention and make us realize that our assumption here, that this assumption here is just not possible. You can't have that and also have this being true. So we can cross that out. That, in fact, I'll call option 1, where they're both positive. Doesn't work. Let's move on to option 2. Now option 2 is, let's say that the thing on the left is bigger than 0, but the thing on the right is less than 0. Let's try that out. Now, if we have the left hand being positive and the right being negative, that means that we have to have x bigger than or equal to negative 1 and x less than 2. And that is possible. X can be both of those things at the same time. So let's now proceed to have a look at the inequality, the question inequality, and see what happens. So I write out that inequality, and just notice that I've left the left-hand side without the modulus because I said it's positive. The right-hand side, because I said it's negative, I've taken negative bracket x minus 2, and that will change it to positive, which is what the modulus does. Let's just solve this. So we've got x plus 1 is less than negative x plus 2. That means that 2x is less than 1, which means x is less than 0.5. Okay, interesting. So if x is less than 0.5, and we also have to remember that x is greater than or equal to negative 1 and less than 2, if we combine those two facts together, we get from option 2 that x has to be less than 0.5 and greater than or equal to negative 1. And if it's like that, that will satisfy this and this and this. Okay, so that's option 2 done. Let's move on to option 3. Option 3 is going to be that the one on the left is negative and the one on the right is positive. Like so. That means, of course, that x has to be less than negative 1, and also x has to be greater than or equal to 2. What? X has to be less than negative 1 and greater than or equal to 2? That's not possible. That never happens. Option 3, therefore, even before I look at the inequality, it doesn't make sense. I crossed it out. And I move on, finally, to option 4. Now, option 4 is the idea that the both of them are negative, and therefore that the modulus will flick the signs of both of them. So, in other words, we've got x plus 1 has to be negative, and x minus 2 has to be negative, which means that x is less than negative 1, and x is less than 2. Is that possible? Yes, absolutely. You can be less than -1 and less than 2. So let's see what happens there. Putting our inequality, we're going to have negative bracket x plus 1 has to be less than negative bracket x minus 2. Getting rid of the bracket like so, and I'll just scroll up a bit. Subtracting x from both sides, we get -1 is less than 2, and that luckily is always true. And because it's always true, I just have to make sure that I satisfy this. Well, when is that true? When is x less than -1 and x less than 2? Well, obviously it'll be when x is less than -1. And that's my solution. Now, all I have to do now is combine that solution with up here this solution, put those together, option 2 and option 4. When is x between -1 and 0.5 or less than -1? Well, that's when x is less than 0.5. X is less than 0.5. It's my big solution here, because it combines this fact up here and this fact down here. Now it's this or this or this, and that's why it's not the intersection, it's the union of those two answers. Quite a complicated method to get to a relatively simple solution here. So let's see if we can indeed find an easier way to do this, and there is an easier way. It's the graphical way. So if you thought that was overly complicated and you got confused along the way, hopefully you'll see that the graphical way is a lot simpler. So let's have a look at the graph. Okay, so we're interested in the absolute values, each creating two graphs. So the left-hand one, the x plus 1 absolute value, as I'm sure you know, is an ordinary absolute value graph, but it's been shifted to the left by 1. So that means it's intersecting here, and it's going to track up there like that, and across there like that. Rather bad graph, but never mind. The other one, which I'll draw in blue just so we've got a different colour, is the x minus 2 absolute value, and that minus 2 makes it shift to the right by 2, and then it's got that typical absolute value shape which looks like that. Okay, now hopefully you can see that the intersection point, which I'll just circle in red, is at 1/2 or 0.5. Now if we are on the right of 0.5, the green line is on top, as you can see here. That green line's on top over here. But if we are on the left of 0.5, the blue line is on top. Now what do we want? Well, coming back to the question, we want, I'll show it in yellow, the x plus 1 absolute value to be less than the x minus 2. Now where does that happen? That's going to be when the green line is below the blue line. So hopefully you'll realize that that is over here. In this area that I've circled, and of course it continues off here forever, in this area here, the green line, the x plus 1 line, is below the x minus 2 line. And that's therefore our solution. So I can track from that. All I need is for x to be less than 0.5, less than that number there, and then I'm in that yellow area, and I've therefore got my solution. So just tracking back out again, hopefully you can see that for this question it's a lot easier to do it graphically than algebraically. But in the previous question D, I think the algebraic method is faster for finding the intersections and for getting the solution than the graphical method. So that, as I said, you really want to have the two techniques in your kit bag of tools and be able, in an exam situation, to decide which method might be the more effective way to do it. Thanks for listening.